Alright, 6.4 Properties of Vectors. So we're looking at the very first property. Vector A plus vector B is equal to vector B plus vector A. That's known as the commutative property. What that means is that we can rewrite them in a different order and it means the exact same thing. Next part. If we have vector A plus vector B plus a vector C on the outside, that will equal vector A plus B plus C, which means that I can take A and B and put those two together, or I can put B and C and put those two together, add a third vector, and they're equal. So that is known as the associative property. Next one. 1 times vector A is known as vector A. That does not mean that vector A has a magnitude of 1. That just means a scalar of 1 multiplied by the vector is just the vector itself. Let's go to the next one. Some scalar k times vector A plus B is equal to the scalar k times vector A plus scalar k times vector B. That's known as the distributive property. Next one, vector A plus 0 vector results in vector A. That's adding the 0 vector. A scalar times a scalar multiple of a vector is equal to the multiplication of those scalars times a vector, or the other scalar times the vector times the other scalar. This is known as the associative scalar property. What that means, again, is that I can take scalar times A, and I can multiply the two scalars m and n together times vector A, or I can take the original scalar and multiply by vector A times the scalar that was originally multiplied by vector A. So I can change it around. That's the associative property. Very similar to this associative property in the sense that I can rearrange it. So I can rearrange it for addition statements and I can rearrange it for product statements. Again, though, we're looking at product of two scalars and one vector. All right, next one. M plus n times vector A is equal to m times A plus n times A, and that is known as the distributive scalar property. All of these here are different types of properties associated with vectors. It is important that you have an idea what these are called because you could have a question in the multiple choice that asks you which property would you use. So understand the difference between commutative, associative, scalar, distributive, and anything with a 0 vector. Don't forget that there's a difference between the associative scalar and the associative property. All right, next. Example 1, you're asked to simplify 3 times 6. Okay, so you're asked to simplify this expression. The easiest way to do it is distribute the scalar 3 into each one of these, distribute the negative 2 into each one of these, and collect like terms as such. And when you do that, you get 16a plus 12b minus 5c. Now let's look at another one. You're given that a vector is a combination of 3 other vectors, I, j, and k. Now remember, I, j, and k are used exclusively for unit vectors. And vector y is a combination of these 3 unit vectors. And you're asked to simplify 2x plus 3y. So 2 times the x plus 3 times the y And you're to expand and collect like terms. So you're expanding it using distributive property and collecting the like terms, and you get 13i minus 3j minus 4k. All right, and that's the end of 6.4, folks. Take care. Have a good night.